Welcome back. This is a video on how to convert repeating decimals into fractions. Let's say we have 0.1 repeating. This is 0.111111, etc. How do we convert that into a fraction? Well, it's actually pretty easy. All we do is we take the recurring part, which is the 1, and we divide it by 9. And that's it, that's the answer. Let's try another one. Let's try 0.3 reoccurring. This is 0.333, etc. Again, divide it by 9. So we end up with 3 over 9. We've now got to simplify this, so this becomes 1 over 3. 0.5 recurring is 0.555, etc. So this becomes 5 over 9. Now what happens if we get two digits that are recurring? Say we have 0.47 recurring. In other words, this is 0.474747, etc. Well, in this case we take the 4 and the 7 and divide it by 99. We use as many 9s as there are digits in the number that's repeating. So that's the answer there. What about this one? 0.63, where the 6 and 3 are recurring. This is 0.636363, etc. So this becomes 63 over 99, which equals, dividing the top and bottom by 3, this becomes 21 over 33. And in fact, we can divide the top and bottom by 3 again, and we get 7 over 11. Let's try another slightly harder one. Let's try 0.123 recurring. So this time we got 3 digits recurring. So this looks like 0.123, 123, 123, etc. Well, you've probably guessed what we're going to do here. This becomes 123 over 999. Again, simplifying, we can divide top and bottom by 3, so we get 41 over 333, and that's our answer. Now let's try this one. 0.369 recurring. This becomes 369 over 999. This equals 123 over 333. When we divide the top and the bottom by 3, and we can divide the top and bottom by 3 again here, so this becomes 111 and 41, and that's our final answer. You'll notice that because we're only ever putting 9s on the bottom, to simplify we're only going to have to divide by 3. So all you need to know is whether the top is divisible by 3 or not. And for that, there's a bit of a trick we can use. Let's take the number 369. How do we know if that's divisible by 3? Well, what we do is we add up the individual digits. So in this case it's 12, 18. And if 18 is divisible by 3, then this number is divisible by 3. You can even go further if you want, and you can say 8 plus 1 equals 9, and you can say, well, is 9 divisible by 3? If it is, then 18 is, and 369 is. So if we have, say, 0.441, and that's recurring, then that becomes 441 over 999. Now, can we simplify that? Well, we know we can only divide the bottom by 3. But can we divide the top by 3? 4 plus 4 plus 1 is 9, so you know that that is going to be divisible by 3. So, dividing that by 3, we get 1, 4, 7. Dividing the bottom by 3, we get 3, 3, 3. Just checking the top again, 7, 11, 12, so that's divisible by 3 again. So 3's into 14 go 4, and then 3's into 27 go 9, so it becomes 49 over 1, 1, 1. And that's our final answer. Okay, how would you do this one? 0.83 with the 3 recurring. Well, this is slightly trickier because you've got a mixture here. You've got a recurring part and you've got a non-recurring part. So what we're going to do here is we're going to break this into 2 parts. So we're going to say that equals 0.5 plus 0.3 recurring. Now we take the 3, divide that by 9, dividing top and bottom by 3, that gives us a third. So now we just need to add the third back to the 0.5. So 0.5 is a half. We need to add that to the 1/3. This equals, converting it all into 6, this is 3/6 and this is 2/6. So that is a total of 5/6, and that is our answer. Let's just check that on the calculator. So we got 5 divided by 6 equals 0.83 reoccurring, and that's correct. Now let's try this one. This is similar. 0.74 with just the 4 recurring. Okay, so again we're going to break that down into 0.3 plus 0.4 recurring. Okay, the 0.4 recurring is 4/9. That doesn't simplify, so that's our final solution there. The 0.3 is 3/10, and we need to add that to the 4/9. This all converts into 90ths, so this is 40 90ths plus 27 90ths. So that's a grand total of 67 90ths. That can't be simplified, so that's the final answer. Let's check that on the calculator. (67) divided by 90 equals 0.74 reoccurring. Correct. Okay, try this one. 0.212 with the 1 and 2 recurring. In other words, this is 0.2, 1, 2, 1, 2, 1, 2. Well, actually, the 1, 2 is repeating, but also the 2, 1 is repeating. So we can actually say that this is 0.21 with the 2, 1 repeating. So, putting that over 99, we get 21/99. Dividing the top and bottom by 3, we get 7/33. And that is the answer. Quick check. 7 divided by 33 equals 212121. Okay. Now try this one. 0.0048 with the 4 and the 8 repeating. Now the problem we have here is these two zeros. If we can get rid of those, then we can just have the recurring part after the decimal point, and we can then solve this. Okay, so what we're going to do is we're going to multiply this by 100. This gives us 0.48 with the 4 and the 8 recurring. Okay, this becomes 48 over 99. But before we go any further here, we know that this is 100 too big because we've multiplied by 100 here. So to correct for that, we're now going to divide this by 100. And to do that, we're going to add on 2 zeros here. Now we can simplify. So dividing the top and bottom by 2 this time gives us 24 over 4950. Dividing by 2 again, we get 12 over 2475. Adding these digits up tells us that we can divide this by 3. So this becomes 4 over 825. And that looks like our final answer. Okay, let's check that on the calculator. This is 4 divided by 825 equals 00484848. Okay, that's good. We are correct. Here's another proof of 0.7 recurring equals 7/9. Okay, let's say that x equals 0.7777, etc. Then 10x will be 10 times as big, so it will be 7.7777, etc. If we take one from the other, we end up with 9x equals 7. Therefore, dividing both sides by 9, we get x equals 7 over 9. And that is exactly the same as we had up here. So there is more than one way of solving these.
Thanks for watching. If you like this video, please give it a thumbs up. If you'd like to see more, please subscribe.